1, the absolute value, so we're always looking at it as absolute value. Those bars mean always come out as positive. When our A value is greater than 1, we said it was a stretch. When our A value is between 0 and 1, meaning that it's a fraction like 1/2, what happened? You're saying it. It's compressed. These are known as dilations, just so you guys know. So if you ever see the word dilation, that's like the stretching and compressing. We said if our A value is negative, what happens? It reflects over the X. Who can tell me the name of this function right here? What is that function? No, what is the name of that function? It's the parent function. It is the most specific function, meaning it's the default function. It doesn't move left or right. It has the normal out 1, up 1, out 2, up 4, out 3, up 9 pattern. It does not have any changes to it. Maddie, where is the vertex of the parent function? What's your vertex?
0, 0.
Right, there's nothing between and there's nothing at it at the end, so it is 0, 0. Our HK is at 0, 0. So, Jen, if I go out 1 with the parent function, what do I do?
Up 1.
Up 1, because 1 squared is 1. Scam likely?
Answer.
No.
Put on speaker.
Does it really come up like that for you?
Yeah, it's like whenever I get a call from someone I don't know. It just answers.
That's awesome. Mine doesn't
I
do
get like
that.
10 calls from the scam
All right. Ian, if I go out 2, what do I do? 2 squared is 4, so we go out 2, up 4. Remember, this is a quadratic. So, Myra, if we go out 3, we go up. 3 squared is 9. This is the normal pattern. We are going to be stretching and compressing this pattern today. So go ahead and get that written down and then move on to the next page. So the normal pattern is that out 1, up 1, out 2, up 4, out 3, up 9, and we are going to be stretching and compressing that. Yes?
Whenever he subtracts the, whatever they're called, why do they always turn in disorder?
And then if you subtract them again, it's counting by 2. Do you see that?
Yeah.
That is called a, second difference. And I was actually going to talk to you guys about that before the EOC. You know something's quadratic if it has a consistent second difference. Do you see how they have their first difference is not, but their second difference would all be 2? If you subtract them?
Wait.
So if you subtract 5 and 3, you would get...
5 and 3, you get 2.
And then 7 and 5 would be?
2.
So it's because it's quadratic, it's creating a constant second difference. Whereas a linear, if you subtract them, it's a constant first difference. You know what I mean? Because it's always the same. When we do, like, we always go up 2 over 2, up 2 over 2, up 2 over 2. Because it's raised to the first power. So that's where that's coming from. That's why it's doing that.
I want to.
All right, guys. We are looking at y equals 2x squared, but first I am going to plot the parent. If I plot the parent, even though it doesn't ask me, Joe, I go out 1, up 1 squared.
1.
Tommy, if I go out 2, I go up 4, because 2 squared is 4. I'm just plotting the parent right now. Jacob, if I go out 3, I go up 9. So this is the parent. We are going to be looking at the other graph compared to this one here. Hannah, where is my vertex for y equals 2x squared? Here, where is my vertex? What is my h value? Where's my H value here? 0, and what's my K value? So our vertex is at 0, 0. There's nothing there, so we have a vertex at 0, 0. So this is where things are going to start getting different, because what is in front of our x squared? A 2. If we said earlier that this 2 is going to stretch it or make it longer, how does it do that? Well, typically when we go out 1, we go up 1. But this is stretching it, its output, by 2. So instead of going out 1, up 1, we're going to go out 1, up, because 1 times 2 is 2. Okay, good, guys. Let's see if we can get the next one, too. Okay, the next one there, typically when we go out 2, 2 squared is 4, so we're at 4. But it's stretching that 4, so where are we going to be at?
8.
4 times 2 is 8. It's so hard to see it. You're going to really have to count. If we go out 3, you typically go up 9 because 3 squared is 9. So if you multiply that by 2, Maddie, it would be?
18.
Does 18 fit on our graph? No, so we are good there. You need to keep going until you don't fit on your graph anymore. So it wants us to compare this. So there's 3 things you need to look at when you compare it. The first thing is if it translates. So, Connor, does this translate, moves left or right or anything like that? No, it's still at 0, 0. So there's no translation. The next thing you have to look for is a reflection. Tommy, does this one reflect? Does this one reflect at all? Flipped. Does it flip at all? No, because the parent is opening up and so is this one, so there is no reflection. So the last thing you look at is if it's stretched, compressed, or stays the same. So is this one stretched, compressed, or stayed the same? It's stretched. And what is our factor we're stretching by? 2. So we stretch by a factor of 2. Okay, get all of that stuff down and we'll look at the next one. I want to see where you guys are at. Make sure you have it written down. But you have to look at those 3 things when you are comparing. I know this is probably super difficult for those of you that have not been here. Maddie, are you just using the table to do the pattern and multiply it? Perfect. That's fine. Okay, guys. So the next one here, I'm going to put the parent graph on the graph again. So that starts at 0, 0. If we go out 1 with the parent, we go up. If I go out 2 with the parent, I go up 4. If I go out 3 with the parent, I go up 9. So I'm just plotting the parent so I know what I'm comparing to. You're not going to necessarily do this on your homework, but I like you guys to see the difference here. Okay, so where is my vertex, Jacob, for this one here? Where is my vertex for 1/2 x squared?
0, 0.
There's nothing between the x and the square, and there's nothing in at the end, so it's at 0, 0. Yes?
I don't understand what you're trying to find in between the x.
Your h value. So if you look at this original formula, do you see how it's x minus h? Do you see how there's x minus nothing here?
Oh.
So that's why it's 0. Because you don't have to write it if it's not there. Does that make sense? You're looking for the x coordinate of the vertex, that h value. Does that make more sense? Okay. So if we go out 1, we typically go up 1. But Joe, what are we going to be multiplying them all by this time?
2.
What's in front of that?
Or 1/2.
Our a value is 1/2. So we are going to be multiplying by 1/2. So out 1 instead of up 1 will be 1 times 1/2 is 1/2. So we're going to go out 1, up 1/2. See if you're figuring this out, Peyton. Typically when we go out 2, 2 squared is 4, right? But we have an a value of 1/2. What's 4 times a half? 2, so we go out 2, up 2. Okay, Paige. Typically, when we go out 3, we go up 9, because 3 squared is 9, all right? So that's up 9. But we have an a value of 1/2, so what's 1/2 of 9? Half of 9. What did you say originally? That's a third of 9. What's half of it? What's the same number plus the same number that can get you to 9? It's going to be a decimal. Do it in your calculator. Do 9 times 1/2 or 9 divided by 2.
You should really make these graphs a lot bigger.
Yeah.
We can't graph this.
It's hard to without. It's hard to without using too much paper. Sorry. So we have out 3, up 4.5, because half of 9 is 4.5. Okay. Now we don't have this one on here though. But if we go up 4, what will we go up typically?
16.
16. Can we take half of 16?
8.
What is that? Does that fit on my graph? Yeah, so we're going to keep going until stuff does not fit on our graph anymore. Just to give us more points to work with to see what this shape really is.
I'm seeing them, but I accidentally shattered my glasses. Yeah. Yeah, it's not good.
Your life, I swear.
Yeah, it's pretty, yeah.
So let's compare it. Zach.
Morbidly.
Not really.
Oh, are you laughing at me?
Yes. Zach, does this translate at all? Does this go left and right at all?
No.
So there's no translation. Evan, is this reflected at all? No reflection. Tommy, I don't want you to say it the way you said it, although you're not wrong. What is the correct way? Oh, no, you're right. Yep. A compression makes things smaller, so that makes sense. So it is a compression by what is our factor? By a factor of 1/2. What? Because it's not April yet. It's the 26th. No, you flip it when it's April 1st, Zach. No. I was like, why are you asking me to flip the calendar? I thought at first you were talking about the graph. I was like, what?
Go flip the calendar. Just do it.
No, it's not even April yet.
Literally,
It's sort of
just
No.
lift it up.
Easter.
Miss
It's
Brownie.
the present of the sex
Miss
birthday.
Brownie, just lift
And that
it.
happened already.
Yeah.
All right, guys.
Look.
What questions do we have so far? Okay, I'm going to graph the parent one last time, and then I'm going to be done graphing the parent. And we are going to go ahead and still do the other problems, though. So here is my parent graph I am comparing to. Peyton, do you know where, guys,
Wouldn't it be going down though?
we'll talk about, that's the parent. The parent never goes down. We'll talk, the parent is the same every time. It's this. It's opened up, starts at 0, 0, goes out 1, up 1, out 2, up 4, out 3, up 9. Okay? That's why we compare it to that every time, because it's the same thing every time. So we don't have to think about something changing. We'll just compare it to, the other thing we'll change to compare it to. Peyton, do you know where the vertex is on this one? 0, 0. So H is 0. There's nothing between. K is 0. So that means that it's at 0, 0. So the vertex does not change its spot. This is going to be different this time, though. Typically, when we go out 1, we go up 1. What are we going to do this time when going out 1? Ian? Down how many?
2.
So, out 1, up 1. 1 times negative 2 is negative 2. Negative means to go down. So we are going to go out 1, down 2. Typically, when we go out 2, we go up 4. That's why this is here. What are we going to do this time? Yeah, 4 times negative 2 is negative 8, so that means down 8.
And out.
3 would be typically what, Paige? 9, and if you multiply that by negative 2, you would have... Does negative 18 fit?
Down to 8.
It's 8 is right here.
Oh.
Does it have a negative 18 on here, guys? No. Why is that out?
Can you
Yeah, I can. What's up?
One times 2 is like 2, so like 2 for like.
But it's not times 2, it's times negative 2.
Yeah, like that's what I mean, like.
Okay, Tommy, look at this and see if it makes sense. So you always are going to go out that distance. So 1. 1 squared is, what's 1 times 1?
Oh, 1.
1. So we typically go up 1, but we're multiplying that by negative 2. What's 1 times negative 2? So that's why we went out 1, down 2. Okay, look up here again. Sorry, I'm just trying to make sure you're understanding. If we go out 2, we typically go up 4, but we're multiplying by negative 2, which is 4 times negative 2 is...
Oh, 4. Oh, okay, I got you.
Do you see it now? Okay. Anybody else confused with that? Oh my gosh. Zach, it is not April. Maddie, is there any translation at all?
Yeah. Flip by negative 2.
That is not a translation, though. That's a reflection.
Oh, no.
So no translation, but you are right.
These are in April. You should go look.
There's no translation, but there is a reflection, and we don't say by negative 2. We just say a reflection over the x-axis. The negative does that. So this time there is a reflection because it's negative, so it's over the x-axis. Is this one stretched or compressed? It's stretched. We're multiplying by 2. You're taking your height and multiplying by 2, but keeping the same weight. So that's stretching it. You kind of ignore that negative there. So it stretches by a factor of 2. Yes, Zach? Not right now. 1 second. After the next slide. Okay?
And after you make a table.
Okay, are there any questions there? All right. Where is my vertex on this one? Where is my vertex on this one, guys?
4, 0.
It is at 4, 0. This is H, and this is K. If you look at the formula, the negative there makes it a positive. So 2 negatives make a positive, and there's nothing added at the end, so it's at 4, 0. So we did shift it this time, guys. I'm not going to draw the parent this time. We have a factor of what that we're going to be multiplying our up or down values by? 1/2. So Hannah, if I go out 1, I typically go up, but we're multiplying 1 by, so what's half of 1?
Maybe a decimal, right?
Yeah, or a fraction, doesn't matter how you want to write it. It's still a half. So out 1, up a half. Good job. I know, sometimes when you're telling me the same thing I'm saying, it gets confusing, right? You want to doubt yourself. So out 2, Joe, out 2, we typically go up. We typically go up 4, but we're multiplying that 4 by, just set them on my desk. So 4 times a half is, Tommy, when we go out 3, we typically go up what?
I'm sorry, what?
When I go out 3, what do I typically go up?
9.
But we're multiplying by
Half.
our a value of a half. So what is half of 9 is 4.5. Okay, we got to see if the next one fits. If we go out 4, Connor, we typically go up.
16.
But half of 16 is what? Yes, so we can go up 8, that still fits. So we get our parabola here.
What is wrong with you?
Okay. Did I do something?
Is that what you
Do you understand? Or no?
I was going to
Did you forget to multiply by a half?
Miss Brady.
Oh, you forgot to shift it?
Miss Brady.
What?
Freddie Benson's birthday's in April.
Oh, gosh.
You should.
All right, guys. Maddie. Actually, I asked you this last time. Yeah, but I'll ask you again. Is there a translation this time?
Yeah.
It translates what?
4, 0.
So it translates,
Or I mean right 0.
not right 0, right 4 and it doesn't go up or down. I know what you're saying. You're fine. Does this one reflect at all, Zach?
No.
No, the parent always opens up, so this does not reflect. Is this a stretch, a compress, or does it stay the same here? Paige, is this a stretch or a compress, or does it stay the same? Be careful. It's a 1/2. So think about your height again. Think about your height and keeping your weight. If you multiply your height by 1/2 and keep the same weight, are you going to be stretched out? What? You're going to be compressed. Yes, you'll be compressed by 1/2. So when you multiply your height, you are going to be much more, Tommy.
I can explain.
You can be much more plump or wider. So that is compressed by 1/2. All right, so the axis of symmetry is also known as the line of symmetry. Those are the same thing. Those are the same thing. So the line of symmetry goes through the vertex, and that's like where the symmetry is over. What kind of equation is a vertical line? What does this one equal?
X equals 4.
It's always x equals the x coordinate of the vertex. So this is your line of symmetry. That's the line you can fold on, and your parabola's two sides will meet.
Do you know Freddie Vincent's birthday
Come on.
in April?
Stop. I'm trying to teach. Please stop. Guys, please stop. You two, stop. Seriously. Is this a maximum or a minimum, Evan?
Maximum.
The vertex is the highest point?
Oh.
It's a minimum. Your vertex is the lowest point. Your value is the y-coordinate of the vertex because it's talking about the height. When we get into contact situations, you will find out that this is typically height. Y is typically height, and that's why. What is my y-coordinate of the vertex? 0. So it has a height of 0. And then finally, solutions are the same things as roots, zeros, or x-intercepts. It does.
Is it 4?
It's just 4, 0. You'll have one time, and it's at 4, 0. Quickly, yes. Okay, we still have 2 more slides, and then we're going to summarize, so make sure you're paying attention. All right.
I checked my phone for like 2 seconds. I told them all
Stop.
saying
Where is my vertex at, Jacob?
0, 1.
Good. H is 0. K is 1. Ian, for this problem here, if I go out 1, what am I going to do? Good. 1 squared is 1. 1 times -2 is -2, so we'll go out 1, down 2. Peyton, for this problem, if I go out 2, I'm going to go... Good. Out 2 is typically 4, because 2 squared is 4. 4 times -2 is -8. This isn't the parent. I'm graphing that one.
It's supposed to be 8.
It is down 8. It's down 8 from the vertex, though.
Oh.
That's why it's here. So I counted down 8 from the vertex. Out 3 is typically what? 3 squared is? 9 times -2 is?
-18.
Yeah, that's not going to fit.
Wow.
You're like so insane today.
Okay, so we get the parabola there. Jennifer, what's my translation? Up 1. Myra, is this reflected at all? Yes, it's reflected. It's now opening down. Is this stretched, compressed, or the same? Stretched by a factor of 2. Okay, what is my axis or line of symmetry here? What does x equal in this case?
Shut up.
Okay, that's not how you can ask. You could try to be nicer. Please stop doing that, Tommy. All right, x equals what? What? What does x equal?
0.
0. It's always the x coordinate of the vertex. What is this, a max or a min?
Max.
Max, and our value is always the y coordinate of the vertex. So what is the y coordinate of the vertex?
1.
So it says a height of 1, essentially. What are my zeros? Are we at exact points? No, we are not at 0, 1. We do not hit those points there. We are between there. You have to be careful. We're between -1 and 0 and 0 and 1. So you can say it that way, or you can say between -1 and 0 and 0 and 1. Okay, we have one more I need to get through with you guys and then summarize stuff. Questions there? You might need your calculator to multiply it by things like 1/4 or -1/4, whatever the next one is, just so you're aware. Okay, last one. I can go back. You need me to go back? For real.
Chicago, Loyola.
I never would have guessed Loyola Chicago would be in there because I'm from that area. I was like, I would have never said in a million years they would even made it near the, like, anywhere near the Elite 8, let alone the Final 4. Correct, because that's what I would have done too. All right, so where is my vertex, even though it doesn't ask for my vertex here? Where's my vertex?
-1.
Remember, we switched the sign of h because inside the parentheses it is negative, which switches the sign, and plus doesn't switch a sign, so that's why this stays -2. So that's why it's at -1, -2. Okay, this is multiplying by -1/4. So out 1, up 1. 1 times -1/4 is? What's 1 times -1/4? Just put it in a calculator. -1/4. So it's out 1, down 1/4. If you go out 2, you typically go up. 2 squared is? 4. What's 1/4 of 4? 1. But it's going to be negative, right? So we're going to go out 2, down 1. Two squared is?
No.
Is there a way you can like blow that up?
No, I can't. I went out 1, down 1/4. Because we're multiplying 1 by -1/4.
But
Then I went out 2. 2 squared is 4. 1/4 of 4 is 1.
how did you get to the...
Oh, that's in the wrong spot. I just plotted that point wrong.
That's
I see what you're looking at. There we go, right? Is that better?
indeed, yes.
There we go. Okay. Out 3 is 9. We typically go 9. What's 1/4 of 9? 2 and 1/4, right? 2.25, so that's down 2.25. We can still fit more, so we're going to keep going. If we go out 4, we would go up. What's 1/4 of 16? What? So that's -4. I'm going to do one more. If I go out 5, I would go up. What's 1/4 of 25? 6.25, good. So it would be 6.25. Okay, so try to get as many of those points as you can so you can really see the shape. So who remembers what domain is? Who remembers what domain is? Is domain X or Y? And what's range? Okay, the domain. What are the X values that make this true? So, will this hit every single X value? Will it keep going over here? Yes. Will it keep going this way? So that's called what if it hits all the x values? Yeah.
Infinity.
We say negative infinity to infinity or all real numbers, I think somebody was saying.
Is it the R with the dash in it?
This one, yes. The range. Will we ever hit these values up here? What's the first y value we hit? -2. Will it go down forever?
Yes.
So that is negative infinity to -2, which is the same thing as y is less than or equal to -2. Will we ever cross the x-axis? So we have no real roots or imaginary roots.